Okay, let's look at this problem 3.4.35 where you want to use DesCartes's rule of signs to determine the possible number of positive and negative real zeros of f of x equals negative 3x cubed plus 4x squared minus 6x plus 8. So first we'll need to make sure we're clear on what DesCartes's rule of signs actually tells us. So let's look at the first part of this, where the number of real zeros is either the same as the number of sign changes of f of x or less than the number of sign changes of f of x by a positive even integer. So if f of x has only one variation in sign, then f has exactly one positive real zero. So let's take a look at what that means for this problem. All right, here's our f of x, and let's take a minute and look at the number of sign changes. All right, so we notice that the sign of the first term is negative. The sign of the second term is positive, so that's one sign change. Then the sign of the third term is negative, so that's a second sign change. The sign of the fourth term is positive, so that's a third sign change. So we have three sign changes. So what that says is that if we look at what DesCartes's rule of signs says, the number of positive real zeros is either the same as the number of sign changes. So that means that there are either three real zeros, same as the number of sign changes, or less than the number of sign changes of f of x by a positive even integer. So we would subtract 2 from 3. 2 is the positive even integer that's smaller than 3. So we would subtract that from 3 and we would get 1. So, or 1. So there's either 3 positive real zeros or 1 positive real zero. So there's either 3, here let me just change the way, or 1 positive real zero for f of x. All right, so either the number of positive real zeros equals the number of sign changes in f of x, or it's less than the number of sign changes by a positive even integer. And so that would mean in this case 3 or 3 minus 2, which is 1 positive real zeros for the function. Now let's look at the other half of DesCartes's rule of signs, where we want to talk about the number of negative real zeros. Okay, so the number of negative real zeros of f is either the same as the number of sign changes in f of negative x or less than the number of sign changes in f of negative x by a positive even integer. And then the special case, if f of negative x has only one variation in sign, then f has exactly one negative real zero. Okay, so let's remember that f of x is negative 3x cubed plus 4x squared minus 6x plus 8. And we need to look at f of negative x. So we're going to replace every x with negative x. We're going to look at the number of sign changes that result. Alright, so this will be negative 3. If we cube negative x, we're going to get negative x cubed. So we have an odd number applied to this negative, so that result is negative. And we're going to still have 3 factors of x and 1 negative sign. When we square negative x, we just get x squared. And negative 6 times negative x is positive 6x. And we have this plus 8. So we wind up with 3x cubed plus 4x squared plus 6x plus 8. And notice that actually has no sign changes. No sign changes. Every term is positive. So what that tells me is there are no negative real zeros for f of x. Okay, so that's what this tells me. So to kind of sum it up, I have either 3 or 1 positive real zeros for the function, and I have no negative real zeros for the function. Now what's powerful about this is we can so this is really a powerful theorem to be able to just look at f of x and f of negative x and to get this information. Let's look at the graph. Let's go to Mathematica and look at the graph of this. So here I've run the plot function, and I see that I'm getting a good view of the entire function. First of all, it's an odd function with negative leading coefficient, and so it's going to rise on the left end and fall on the right end. And so I see that I'm seeing sufficiently what the graph looks like. Now I decided, after seeing this, I want to come in a little closer. I want to zoom in. So I notice how y is ranging from below negative 2,000 to above positive 3,000. And my x was going from negative 10 to 10. I'm going to zoom in closer. So I'm going to take x from negative 3 to 3 and y from negative 10 to 10. And notice how that allows me to see that there is exactly 1 positive real zero. We knew there were either 3 or 1 positive real zero. So here we see there's just 1. And as we determined from Descartes' rule of signs, there are no negative zeros. Remember, zeros are x-intercepts. So there is 1 positive x-intercept, no negative x-intercepts, just as Descartes' rule of signs informed us.